Hey everybody, now that we've gone over the derivation of the formulas for rotated axes, principal moments of inertia, let's try it out with an example. So let me modify this one just a little bit. Let's find principal axes about a point through the centroid of this shape instead. So how do you do that? First, let's find the moments of inertia about these coordinates. So let's do that first. So this out of the appendix. This looks like a composite of two rectangles, one with the centroid here and one over here. Okay, so let's say for this one, Ix is right here, 1/12 base height cubed. Let me just put the numbers. 1/12 base height cubed. 3 feet, 1 foot cubed. But that's about here. We need to do the parallel axis theorem to here. So plus the area of this shape, 3 square feet, times this distance squared. So that's half a foot, 0.5 squared. Okay, so this is for this rectangle. Now this one. So about this axis, 1/12 base height cubed. So the base for that one is 1, height is 3, plus the area of this one, which is 3, times this distance squared, the distance between the parallel axes. Okay, so here to here is 3, so here to here is 1.5, so here to here is 2.5 squared. Okay, Iy here is 1/12 height base cubed, 1/12 height base cubed, plus we need to go from here to here, so the area times this distance squared, so 1.5 squared. Okay, now this rectangle about here is here, 1/12 height base cubed, 1/12 height base cubed, plus the area of this times this distance squared, 0.5 squared. Okay, now the product of inertia for this rectangle about its centroid, 0, plus the area times this distance times this distance. So 0.5 and 1.5. Okay, now this one about its centroid, 0, plus this area times this distance times this distance. So 0.5 and 2.5. Okay, and then just punch that in the calculator. So did that earlier. Okay, now that's about these axes, but let's get it to the centroid. But where's the centroid? So let's figure out where the centroid is. So it's an area weighted mean position. So for this one, the centroid is at 1.5 feet times this area plus the centroid of the x component of the centroid here is 0.5 times this area divided by the total area. Okay, and then the y component of this, 0.5 times this area, plus the y component of this one, 2.5 times this area, 3 over the total area. Okay, and then that's 1 and 1.5 feet. Okay, so we know the location of the centroid. So what we want to do is we have this shape. We know the location of the centroid. Let's move from here to here, and then from here to here. I'll call this x centroid, different coordinate system. So for Ix about the centroid, is it more or less? Like which one is more, about here or about here? About an axis going through the centroid is a minimum. So this one is less, this one is more. How much less? The area times the distance between these two axes squared. So the distance between the two axes here. Okay, so let me write that down. This squared times the area. Okay, so this is the answer right here, 22. 1.5 squared times the area. Right, so this is 22 minus 1.5 squared times the area. Okay, so this is 8.5. So see how this is less? It is in fact a minimum. Okay, why? This one is less. How much less? The distance between these two axes, which is the x component of the centroid, squared times the area. Right, so that's 10 minus 1 squared times 6. So that's 4. And the product of inertia is less. How much less? This distance times this distance times the area. So this times the area. Okay, so 6 minus 1 times 1.5 times 6, negative 3. Okay, so we got Ix, Iy, Ixy about the centroid. So if we want principal axes, that happens at this angle right here, at this angle right here. So where theta is half arctangent of 2Ixy over Iy minus Ix. And then you just take the numbers and just plug them in. Right, so 2 times Ixy, negative 3, Iy, minus Ix. Punch that in the calculator. There you go. So you have the centroid here. You just have to rotate your coordinates 26 degrees. Right, so going through the centroid was here. We just rotate to here. I'll call it x prime, y prime, by this much. 26.6 degrees. And those are principal axes. And what happens at the principal axes? I x prime, y prime becomes 0, and then Ix becomes a principal moment. You just take these 4 values, ix, iy, ixy, and the angle, and all of that goes here. ix, iy, ixy, the angle. And then the answer you get here is either a max or a min. The answer you get here is either a max or a min. Right, so this becomes 0, 1 becomes a max, 1 becomes a min. Okay, hopefully that was helpful. So keep practicing these problems. Let me know if you have questions, and I'll see you in the next video.